Okay, now there are a lot of other things I could have asked, but it was little touchy on this, okay? Only about half of you got it right. A lot of you didn't know where to put the points. Okay. And didn't know how to label the grid. Well, if you didn't know where to put the points, you wouldn't be able to do this. Here's where we start. And you draw center line. Now, you think of this line as being halfway from here to here, and then you're going to go halfway from here to here and halfway from there to there and so forth. Okay. And this is the center line. Okay. Now, halfway between x equals 8 and x equals 40 is x equals 24. 40 minus 8 is 32. Half of that is 16. Add it to 8, you get 24. That's one way to do it, one way to see it. You should see it both ways. Sometimes it's easier to do it one way than the other. Okay. Or 8 and 40 is 48. Divide that by 2, you get 24. And similarly, this line is going to be y equals 12. And then you're going to get a bunch of other lines that you're going to label. Then you're going to get a curve. That's not the way the exponential curve looks, but there's a curve. If I say, predict y if x equals 32, where's 32? It's between 24 and 40. Which one's it closer to? Well, if you label all your lines, 32 is one of the lines you're going to label. Okay. So here's the line where x equals 32. Here's the point on the graph. Y equals what? Between 12 and 20. Halfway between 12 and 20 is 16, but this is a little less than halfway. So I'd say 14 or 15. 14 and a half. Okay. Now we did all this, okay, and it was assigned. Should be done meticulously in your notebooks. Now, what we normally be doing right now is some heavy algebra. Okay, we're doing this so you have pictures to hang everything on, and we're introducing the algebra slowly. You have to get these done, and you got to get them done as well as you possibly can, so I can look at what you're doing and see what kind of mistakes people are making. Well, the main mistake I saw here was mostly good grids, but there was some bad stuff in the grids. You got to follow the instructions. You have maybe have to review what we did in class. Okay, go back to the videos when we were constructing the grids. Flip through the video till you find it and get it right. This is absolutely necessary. Okay, you have to. I mean, some of you are doing great, and some of you are a little shaky here. Okay, so mainly addressing people whose homework looked a little shaky, and also the third assignment was due today. Okay, that was on the assignments page, and most of you did that. A couple of you didn't, but you know, with all the power outages, you might not even have power on Tuesday to find out you're supposed to do this. But you got to get that one done, okay? Because I'm going to be talking about 4 and 5 here. So you got to nail this stuff. This is not difficult. You just got to do it. You got to focus and do it, okay? And if you're not doing it well, again, you know, we had an ice storm. I was only out for power for 10 hours. I had to hustle around in case it was going to be 14 days like it was in the last one. But they had a crew in the road within a couple of hours after the power went out. And they worked all day and got it. As you know, I'd have bought them an ice cream cone if they hadn't disappeared on them. That don't bother them. You know, they got their job to do. I'll wave. Just let them know I appreciate them. But some people There's people are still out. And roads are still icy in places, okay? So there are a lot of reasons people might be behind on this, but don't let it be because you're not giving these assignments your full attention. Give them the time, give them the attention. Because, I see a bunch of people do this. People did it right in class a week ago. But you come in today, if you didn't do it right, it means you didn't learn it. Okay? You got to learn it as you do it because everything builds. Now, sometimes you don't learn to do one assignment until you do the next. You do the next assignment and say, oh, what was that again? I better go back and look at the first assignment. Okay? And you say, oh, I didn't really understand this, but now I know how to use it to get this, so now I understand it. You understand what I'm saying? These things are designed to move in very small steps on each topic, on each thread. Another thing I will say is on your website, has anybody looked on the assignments page at the AI summaries? Did anybody try to look at the AI summaries and they wouldn't open? Okay. Well, yesterday I found that some of them weren't opening because my front page editor was screwed up. It wasn't screwed up. It was doing something that I didn't expect it to do. Okay. Turns out that if a file is open, then it thinks that it wants me to link to my computer, not to the network. If I navigate to that same file and insert it, it does it right. Okay, that's ridiculous, but that's the way it is. It's an anomaly of the thing. Anyhow, I caught on to that finally and spent a couple hours yesterday fixing those links. So they should all work. The AI summaries, I think, are doggone good. They tell you in words quickly what you need, what we did in class. I find them to be complete. Sometimes the AI comes up with phrases and terminology that I really like. Now, if it comes up with one that I think is misleading, and it can, because it says a little more than what I really said, okay? And sometimes it just gets a little offbeat. So very rarely, but occasionally I have to just delete something. So yeah, I proofread these things, a couple of pages. They're easy to read. I know what they're supposed to say. Sometimes not. Most of the time I'm very impressed with the way they say it. Okay. So you get things from printed material easily. It's a good source. I recommend that at the very least, you read the AI summaries. They don't take that long to do. I'm giving ChatGPT $20 a month. And from the time YouTube finally gets my document posted and does its transcription, then I just got to copy that transcription. I've worked with the AI. I've told it the way I want these things formatted and so forth, and just exactly what I want. And boom, I enter it. It takes 3 or 4 minutes, and it's there. I copy it, proofread it, put it into the website. Okay, it's very slick, saving me a lot of time. So anyhow, that's going on. And I want to know if that's working for you. So be taking a look at it. Okay, they have other sources. There's a text, you click on the assignments, go down the assignments page, you see text, you see videos, you see all kinds of stuff. Okay. Now, actually, you don't at this point because we're not using open math yet. But we will. We'll start using that toward the end of next week. After we get these 6 assignments or these 5 assignments nailed. Okay. But you got to nail them. Now, if you didn't get them for today, well, again, there are many reasons that could be. But if it's because you didn't think it was important enough to do, even though you did have time, change your thinking. Get them done on time. And if you just can't, you know, let me know what's going on. It might give you, it's not a matter of extension. I'm not grading them right now. The other thing, late next week, there'll be a test over these. And you're gonna have them right. Okay? So start getting them right now. Start with the first assignment if you have to. Get everything right. If there's something you don't understand, you can always email me. Okay? I'm glad to give you more explanation when you need it. Sometimes you email me something, I'll email you back, say, I'm gonna hit this in class next time. Because you need to see it written out. Okay? That sort of stuff. I want you to succeed here. And you want to get in the habit of succeeding. These things I'm giving you, some of them, you're gonna get confused once or twice, maybe. You're gonna make mistakes, but this is something that's very achievable. Okay, even if your math background isn't as strong as we would like it, we're gonna build your math background. Okay. So messages, get it done. Anyhow, I shouldn't have had to do this. Okay. Because that was on an assignment I gave you a week ago for the storm. Another thing I think I saw was a grid that looked like this, at least below the axis. I kind of saw this. That would not be the right grid, but it looked like the right grid for a type 3 graph, but we haven't talked that much about it. Okay. So it looked like you're doing it right. Make sure you understand the rules. Halfway there. Halfway from there to there, well, there's the line. Halfway from there to there, there's the line. You're going halfway. If you keep walking halfway to the wall, you're going to get closer and closer, and your distance from you move is going to get smaller and smaller, right? Well, that's what you're doing here. Okay. And then here's your halfway, then halfway from the edge to the center, and halfway from this edge to the center. The rules are very clear, and they're written out. I'm pretty sure AI wrote them out correctly. So you can even look at them. Now, there are many things that I really need to talk about today. Since we're on a short day and I had to spend time talking about this, oh man, hang on. Another thing is I came in and this computer locked up. Came in a half hour early to do stuff. Had to spend a half hour getting the computer straight. So I'm running behind here and had to reboot the computer. So I don't have what I thought I was going to have, but I'll find it here in a minute. Okay, here, and here. Go to the end. Okay, I'm not going to talk about, well, maybe just a little. Okay. There is a problem somewhere in this sequence. Dude, I was recording all that, wasn't I? Okay, that's all right. Okay. Here's the line y equals 0. Here's a point on the line. Okay. Now I'm going to draw some equally spaced vertical lines. Pretty well equally spaced. Yeah, it's a little fat. Okay. I'm gonna move to the next line, and I'm gonna move twice as close to the y=0 line. That's gonna give me a point here. It's about twice as close to this as it is to this, isn't it? Okay. Now, just slop this down. Don't be meticulous. We only want to take 30 seconds for this. I want you to copy what I've got here and then show me where the next 4 points go. Okay. Now, if you keep doing that, twice as close as this, put you here. Twice as close as this, put you about here. Twice as close to this, put you about here. Twice as close to this, puts you about here. You'd probably go twice as close once or twice more if you got a thin pencil, say, thin point on your pencil or whatever. I'm writing with chalk. I'm kind of done here. So here we have. Okay, that's an exponential shape. This is a decreasing exponential shape. Now, if you had labels on these grid lines, you'd be able to tell what the numbers are. And if you had labels on horizontal lines, you'd be able to tell what the values are. But this can represent any decreasing exponential, meaning how quickly drugs in your bloodstream, talking legal drugs here, okay? Say an antibiotic. This is what happens after the dose gets into your bloodstream. If you get an injection, let's say, it's pretty much instantly in your bloodstream, and your body instantly starts breaking it down and getting rid of it, okay? And the concentration does this. Now, if you take another dose, that's going to up your concentration. It's going to take you up higher. If you take a dose here, you take this much of a dose, you're going to be up here, and you're going to start falling exponentially. Okay, and you could draw that if you're inspired. Wouldn't be a bad thing to draw. It's easy, very easy. Okay, I'm not going to do it for you though, unless you try it and then need to see it. So if somebody tries that, we'll see. Last night, I accidentally took a diuretic before I went to bed. Okay, that's what works on your kidneys. Okay, so oh man, I'm going to have to be getting up all night. Well, I'd taken one the day before, the morning before, so I didn't have that much fluid left in me. So I made it halfway through the night and had to get up. Made it the other half of the night. Wasn't bad at all. Okay, usually I have to get up once anyway. So yeah, what happened? I was about here on the curve, and then I took this much, which put me up here. So I was overdosed, and now, I'm probably down about here right now. I didn't take one this morning. I don't want to get dehydrated. I'll just get back on my schedule next time. If you know this, you know how to think about, gee, what should I do? There's a rule. What's the rule? Well, the rule is if you miss a dose, just go to the next one, because you might not want to get overdosed. Okay? With the diuretic, it didn't matter. And I had to get my night's sleep. Otherwise, I'd have been even more worthless in class than I am now. Okay. So anyhow, okay, now labeling, this is half-life. And each one of these is a half-life. We talked about doubling times last time. Make sure you are aware of that. Make sure you remember how we did that in the picture on the board. You might well have a quick sketch in your notebook, okay? Not required to have that quick sketch, but it helps if there's a graph that has important characteristics that you sketch it. Okay. And if it doesn't help, don't do it. The goal is to learn the stuff. Okay. Well, more time than I wanted to spend on that, but there it is. Now make x equals 5, so the calculations are easy. Okay, there's a straight line. Now I just made this line up. Okay, and here's another straight line. Where do the lines cross? What's the x value where they cross, and what's the y value where they cross? Well, the x value looks like it's about halfway between 0 and 5. I'm going to say it's approximately 2.5. Y value is between 10 and 25, somewhat closer to 10. I'd say y approximately equal to 12. Make sense? It's an easy question. And it comes up, I think, on the third assignment. An incoherent note related to this next one. I'm going to ask you to do this while I clean another board. You add these two equations. I'm going to set this way over here so you can see it. I need to wash this board quickly. Okay, it wasn't recording. But here we've got a window with the origin at the center. The origin is a point where x equals 0 and y equals 0, as I assume you know because you've seen coordinate axes before. So this is your x-axis, and this is your y-axis. We got a point up here. And let's say that point is 32, 32. Then I ask you to sketch a bunch of points. Okay. Now, in this case, we're not going to use the type 1 or type 2 grid unless you really want to, because the shape is going to be pretty arbitrary. Okay. So I say, let's say I ask you to locate the points negative 27, 24, negative 13, negative 7, 4, 18, and 21, negative 20. Okay. How are you going to locate those points? Well, first of all, this point's 32, 32. So this line is x equals 32, isn't it? And this line is y equals 32. Makes sense? Everybody understands that? So don't say, because we're recording, but what's this line? Think it in your head and then I'm going to tell you. How many know what that line is? Okay, I think most of you do. And if you don't, well, if this is in the center, then this line is halfway between this line and this line. So you go from 32 to 0, you got to go another 32. So you get x equals negative 32. That should be obvious. But if it isn't, you can always, you say, in class, you said this, and I didn't understand it. Can you explain it? I'll email you back. Okay. Incidentally, email me from your VCCS account. I've said that before. Not from Canvas. It's Canvas email is a mess. Okay, when you're trying to find things, when I'm trying to find what I'm trying to find. It's secure. It's a lot of good things, but it's not useful for that purpose. Okay, so anyhow, this is going to be y equals negative 32, should be easy to understand that. So now we can locate these points. This is at x equals negative 27. Well, 0 is here and 32, oh, negative 27, probably long here. Let's just get our x equals negative 13. Well, 16 would be here, so negative 13, say 16. Here's x equals negative 13. And then x equals 4, that's going to be pretty close to the center line. And x equals 21, closer to 32 than is 0, about 2/3 of the way or something like that. So x equals 21. I don't claim that those points are precise. I don't care if you make them precise as long as they're reasonable. Like if you put 21 to the left of negative 27, there's something wrong. Okay, and you need to think a little bit more about it, but I don't think anybody's going to do that. Okay, now negative 27, 24. So we need y equals 24. Well, that's 3/4 of the way. Actually, this is pretty easy. So here's y equals 24. And now here is a point. This is our first point. Negative 13, negative 7. Here's negative 13, negative 7 for the y. Well, this would be negative 16, here would be negative 8. Y equals negative 7 is probably about here. And that point where x is negative 13 intersects the line y equals negative 7. That's our point. Then 4, 18. Here's the x equals 4 line. 18 is between 0 and 24, about 3/4 of the way. 24, not 3/4, but it is 3/4. It's a matter of me. So that's y equals 18. And we're going to have that point. Now I put an X at the origin, and I don't want to do that. I'm going to put a dot there. That's not going to be one of our graph points. It might not be. Okay, 21, negative 20. Well, where's negative 20? Oh, it's not about here. So this is reasonably accurate. So now we can draw a smooth curve from left to right that goes through all these points. Okay. Now, I'm not going to come down here and turn around at this point unless there's a good reason to do it. I'm going to come down a little bit lower than this point, so it's easy to get up here and go through this one smoothly, and that gets me down here. Okay. Then I can continue the curve until it reaches a boundary. Continue the curve in a smooth manner, logically. It's a pretty nice smooth curve, if I say so myself. If you wiggle around trying to make this a low point, and this a high point, and stuff like that, it's okay, but it's not going to be as smooth. You want to strive for smoothness, and there are many reasons for that. As you get into the rest of pre-calculus and into calculus, especially to understand intuitively what smoothness is. Okay, So there's a nice smooth curve. Then I ask you to estimate, okay, where does this thing leave the window? It looks like it's at about negative 28, 32. Okay, you know, what are the coordinates of this point? What are the coordinates of this point? What are the coordinates of the low point? What are the coordinates of the high point? Okay. How many peaks and how many valleys? Well, there's just one peak here and one valley in this case. You understand what I mean? I call this a peak, call this a valley. Okay. So like a mountain range here. Okay. So that's really a pretty easy question. Then I ask you to tell me all the x coordinates that correspond to well, let's say if y equals 10, what is x? Well, the line y equals 10 would be, say, about here. Actually, it's not drawn very well. Here's the y equals 10 line, and I've got 1, 2, 3 points. So I would have 3 x values. I have an x value here, an x value here, and an x value here. You could estimate what those x values are. If I give you an x value, there's only one possible y value if you follow the instructions, which were to sketch the thing from left to right. Never backtrack. That's an important concept. It's a definition between something is a function and something that's not a function. And functions are the main topic of this course. Yeah, makes sense? So that should be an easy problem. Just follow the instructions. If you have trouble, let me know. The type 2 grid is within a window. And you've already seen it. So far, it's the same as the type 1 grid for the exponential. But it has 2 additional lines, one halfway from here to the center, one halfway from here to the center. So what we're doing is 2 subdivisions from the right edge toward the center, 2 subdivisions from the left edge toward the center, each a halfway subdivision. Okay, we need all those lines. Okay. Then we do the same thing we did for the exponential graph, halfway from the top to the bottom, halfway from there to the bottom, halfway from there to the bottom, and halfway from there to the bottom. In other words, halfway from the top edge to the lower edge, halfway from that to the lower edge, halfway from that to the lower edge, halfway from that to the lower edge, and then halfway from that to the lower edge. I've drawn these before, but now you got to be able to construct it, okay? And your rule is very simple, but not quite as simple as it was for the exponential function. Start at the top left. You move to the next vertical line, and then you skip one horizontal line and make a mark on the next. Okay? Then you do that again. You move to the next horizontal line, to the next vertical line, skip a horizontal line, mark the next one. Then you move to the right to the next vertical line, you skip a horizontal line, and you sketch a point, which will be, if you've drawn the right number of lines, I've got 1, 2, 3, 4, 5 construction lines between the boundary lines, right? Horizontal. 5 horizontal construction lines between the boundary lines. Each twice as close to the lower boundary as the one before it. I also put a red dot here. Not sure that's in the instruction, but you might as well see the red dot. It's the same place it would be for the exponential function incidentally, but in this case, one of your graph points is on the red dot. And that red dot, well, let's see what we do with that. Okay, then after we've hit the lower edge, we can't go any lower and stay within our window, but that's not the reason we turn around. We just turn around and go back up, which means we go one to the right and then two up. One to the right, two up, one to the right, two up. And then we draw a nice smooth curve. If drawn correctly, it's symmetric about this vertical center line. This half reflected through this vertical center line is this half, okay? Every point here corresponds to a point in equal distance across the vertical center line. So there's your toolkit, basic toolkit, squaring or quadratic. I said graph. It's not a graph till we label the scale. We use the word quadratic shape. We just get the shape, and then we can put numbers on it and make estimates, which is just as easy to do as it is with any other graph. Okay. Now let's see if there's anything else that